In section 7.3, here we have trigonometric substitution. I know that's what the last one felt like, but we call it trig identities because there you're using trig identities, and here we're substituting trigonometry. So we're going to start off with an integral of the form mentioned right here. So we have an integral of a squared minus x squared dx, where we have a circle or an ellipse, where a is greater than or equal to 0. So if we had an x in there, then our u substitution would be easy, but without the x, it's much more difficult. So like this says, if we change the variable from x to theta, and then we can use x equals a sine theta, the identity allows us to get rid of the root sine, and you can kind of see the manipulation there. It comes based off of the right triangle, which is the radius of the circle or the ellipse. So they go on to explain it, and what you can see here is it's kind of using a reverse. It's called inverse substitution because you're actually taking f of x dx out and you're replacing it with this composite function. It's really not difficult. There are two methods to do it, so we're going to call this version A. This is the way that people who do this regularly use. There are two types of math people in the world, those who memorize and those who understand it and do it that way. So we're going to look at both, but this is version A. So here you can see a trigonometric a table of substitutions. I'm going to go through this and how to build these expressions right here. I'm going to go through how to build these expressions and where they come from. You're welcome to memorize it. They're all based off of the identities over here, but a lot of people who memorize it end up later switching to the triangles form. I call it triangles, so we're going to look at it that way. Let's look at a couple problems. So let's start off with the example 1. It says the integration of the square root of 9 minus x squared over x squared dx. So the way this works is we're going to build a right triangle. First of all, you always check u sub. If we let u be 9 minus x squared, then du is negative 2x dx. So that's not going to work, because I have an x squared in my denominator. So that tells us u sub isn't going to work. But whenever you see problems, you should always try u sub first. It is the easiest tool in your toolbox. So when we start these problems, we're going to build a right triangle. And you're thinking, how does that help me? Well, think about trigonometric functions. Here's theta. Now, 9 minus x squared, remember that I have a value here, and a value here, and that's trigonometric functions. So I know that the Pythagorean theorem says a squared plus b squared equals c squared. So that tells me c is the square root of a squared plus b squared. Do you understand that? So that indicates to me that if I have a plus, it's my hypotenuse of my triangle. And then I know that a squared plus b squared equals c squared. So b squared or a squared, either way, equals c squared minus a squared, and then b equals the square root of c squared minus a squared. Now we only have positives because we're dealing with lengths of the triangles. So, but do you see how this is your second form? So when here's the biggest hint. When it's a minus, it's a leg, and when it's a plus, it's the hypotenuse. And you say, what does that mean? Well, let's get there. In this case, I have a minus, which means it's a leg. So I'm going to show you how to build it. Here I'm going to build my triangle very tall. So the pieces of my triangle are, because I have the square root of 9 minus x squared, I know that this follows the form of down here, where b equals the square root of c squared minus a squared. So I'm going to take the square root of this to be 3, and that's one piece of my triangle. And the square root of this to be x, and that's the other piece, another piece of my triangle, and this is the final piece. Now, it's minus, so that indicates a leg to me. So my hypotenuse is going to be 3, because I can see that. After you've done a bunch of these, you'll kind of pick up on the pattern. And then I'm going to have an x here, and I'm going to put my square root here. How did you get that, you say? I'll show you in a minute. If I write my triangle like this and I check it using Pythagorean theorem, now I say x squared plus the square root squared equals 3 squared. So I get x squared plus 9 minus x squared equals 9. And the x squareds cancel, so 9 equals 9. Now that's the big part of the problem, is I set my triangle up correctly. And I need to put a theta in there as I use it. Let's talk about what happens if I hadn't set it up correctly. I still have 9 minus the square root of 9 minus x squared. So the square root of 9 minus x squared. Now I still know this is a 3, and this is an x, and this is another piece. So my two options are a leg or the hypotenuse. So if I put this on the hypotenuse, now I have 3 squared plus x squared equals the square root of 9 minus x squared squared. So 9 plus x squared does not equal 9 minus x squared. That tells me that it's not on the hypotenuse. It should be on one of the legs. And whatever comes first in the subtraction, the square root of that will always be your hypotenuse. Those are patterns you're going to pick up on. So let's go back to the problem now. It says the integration of the square root of 9 minus x squared over x squared dx. So we're going to draw our triangle. The minus indicates it's a leg, so I'm going to write the square root of 9 minus x squared on this leg. You can write it on either leg, it doesn't matter. And then remember, I'm taking the square root of this to be 3. That's going to be my hypotenuse because it's before the subtraction. And the square root of this is x. If there's no subtraction, the square roots, you would have a square root of like 9 plus x squared. Well, that tells me that the square root is my hypotenuse because of the plus. So that means one leg is 3 and one leg is x. So these are things that you'll learn as you practice. Let's go back over to here. Now you need a theta. Most people put theta in this bottom corner. You can put it wherever you like. There are 6 trigonometric functions, so there are 4 different ways that you could set this problem up. Our life is easier with sine and with cosine, so I'm going to prefer sine or cosine, and I really don't want to work with that messy square root, so I'm going to say I'm going to do cosine because I want the adjacent and the hypotenuse. You have to use the hypotenuse because you know it. That's your constant here. You don't want 2 sets of variables. So let's let cosine of theta equal x over 3. And then let's multiply the 3 over, so x equals 3 cosine of theta. Now those 2 things become very important as we work. Let me just clean it up a little bit. We're going to use these extensively. So x equals 3 cosine theta. Then dx, so we're going to do dx, and the derivative of cosine is negative sine. So we have negative 3 sine theta d theta. Now we're not actually solving for d theta in this case because it's not u sub. But if you look, what we have here is in the problem, we have everything in terms of x's. We have an x here, and a dx. So we're going to replace all the x's with 3 cosine theta, and we're going to replace all the dx's with negative 3 sine theta. So this is called inverse substitution because we're going to take out the main variable and put in a different one. So we have the square root, we have the integration of the square root of 9 minus, now x is 3 cosine theta squared. And on the bottom, we have 3 cosine theta, quantity squared, times. Now, those of you who leave off your dx, you really need to be careful here because you can't, if you're reverse subbing, so if you leave it all off, it's not going to work. So in dx, I'm replacing dx with negative 3 sine theta d theta. Now you're going to do the algebra to fix this up. So we do the square root of 9 minus 3 squared is 9 cosine squared theta over 3 times 3 is 9. And then we have cosine squared theta times negative 3 sine theta d theta. So let's factor a 9 out here. So we have the square root of 9 parentheses 1 minus cosine squared theta. And on the bottom we still have 9 cosine squared theta, negative 3 sine theta d theta. Now this can cancel a 1 and a 3 here. So we have the square root of, in the top, the square root of 9 is 3. We can pull that out as a 3. And we have the square root of 1 minus cosine squared. Now we know that sine squared theta plus cosine squared theta equals 1. So 1 minus cosine squared theta is sine squared theta. And on the bottom we now have 3 cosine squared theta. And let's take this negative out front. And then we have sine theta d theta. The 3's cancel. So we have negative. Now the square root of sine squared is sine theta. And on the bottom I have cosine squared theta. And here we have sine theta d theta. So this is negative square root. Now sine squared times sine squared, sine times sine is sine squared theta. Because remember this is technically over 1. Times over cosine squared theta d theta. Now this is negative tangent. Because sine over cosine is tangent squared d theta. So it works, the square root is gone and we're down into something that we did last time because tangent squared is what we integrated in the last section. So take a minute and think about all of this before we turn to the next screen. So tangent squared theta is equal to secant squared theta minus 1. Well, we know the antiderivative of secant squared, and we know the antiderivative of 1. So when we integrate that, the integration of secant squared is tangent theta, minus, and the integration of 1 is theta, and we throw plus c on here. Now, here's the important thing. Let's distribute that negative before we go any further. Here's the important thing. We did not start off with theta, so you need to always, when you finish a Calc 2 problem, you need to always look at it and think, did we start with that variable? We did not. We started with x's, so let me pull that back in here. You can see it on your paper, so let's look back at it. I just added in a screenshot of where we started the problem. So it says negative tangent theta. What we're going to do is we're going to read the triangle. We're going to come over here to theta. And tangent is opposite over hypotenuse. So that's the square root of 9 minus x squared over x plus theta. Now if we come back to the start of the problem, we know that cosine of theta equals x over 3. And we need to solve for theta. So let's... So we take the inverse cosine of both sides. So theta is inverse cosine of x over 3. That means what angle has a cosine of x over 3? So we say plus inverse cosine of x over 3 plus c. And that's your answer. So let's look at another one. Before we do, notice that going back to your original variable is just reading the triangle. Once you set up the triangle and you make the substitutions, you're okay. So your trigonometry is working through the things that you have. So just pay attention to what your triangle says, and let's look at another one of these problems. The next problem says the integration of 1 over x squared square root of x squared plus 4 dx. So let's draw our triangle, and I have a square root of x squared plus 4. Do you see the plus in it? You got to look at patterns. The plus tells me that that's going to be on my hypotenuse because I have a squared plus b squared equals c squared. So you see how the a squared plus b squared, when I take the square root of that, I get c here? That's the helpful hint. So when I'm going to take the square root of this to be x and the square root of this to be 2. It doesn't matter where you put them. It depends upon if you want to work with sine or cosine or whatever. But because these are legs, I'm going to put the 2 here and the x here. So then I have the square root of x squared plus 4 and theta. The biggest thing you need to do next is check that your Pythagorean theorem works. So I have 2 squared plus x squared is the square root of x squared plus 4. So 4, quantity squared. So 4 plus x squared equals x squared plus 4. True by the commutative property. But you have checked that your triangle is correct, so that's the important part. Now, I drew my theta in the bottom left corner because most people do. And some of you want to know, does it matter where I put the 2 and where I put the x? Technically, no. If you don't like where you put them, move your theta to the top of the triangle. I put them here on purpose, and I'm going to show you why in just a second. But we need to read the x here and the 2 here. So when I read those two values, I'm looking at tangent. So we're going to let tangent of theta equal opposite over adjacent. That's where I put the 2 where I did, because I didn't want to end up with the 2 on top and the x on the bottom. You could solve that if you had tangent theta equals 2 over x, then x tangent theta equals 2, and x equals 2 over tangent theta. It's harder because you're working with cotangent, and I don't work with cotangent as well as I do tangent. Most people don't. I prefer tangent. So I drew my triangle so that I could have tangent equals 2 over x. So let's look at this problem now. I'm going to solve this for x. So x equals 2 tangent theta. So dx, you need to always find the derivative. We are in calculus. So dx is 2 secant squared theta, d theta. The d theta is going to make or break you here, so be careful with it. I'm going to write a little smaller, see if I can make this fit. So we have 1 over x is 2 tangent theta, quantity squared. It's not going to help to be smaller. The square root of parentheses 2 tangent theta, quantity squared, plus 4. And then dx is 2 secant squared theta, d theta. So let's work through this. I have 2 tangent theta squared. This means I have 4 tangent squared theta. And then inside the square root, I have 4 tangent squared theta plus 4. And out here I have 2 secant squared theta, d theta. Now this 2 can cancel with this 4, right? I often don't cancel till the end, but it's all good. Now my secant squared, I could write it on top. So I'm going to write secant squared theta on the top because it's technically over 1 over here. And then I have tangent squared theta here. Square root of 4 parentheses. I'm going to factor the 4 out of these two terms. Tangent squared theta plus 1 d theta. By the way, if you can't factor that 4 out, you've messed up somewhere. Oh, and there's a 2 in front of that tangent squared. I almost forgot that. So now we have the integration of, the top is still secant squared theta. The bottom is 2 tangent squared theta. And then the square root of 4 is 2. And then we still have the square root of, instead of calling it tangent squared plus 1, we know that value is secant squared theta. Those identities that you need to know. So let's make a note here. Let me remind you that, I guess I just did, secant squared theta equals tangent squared theta plus 1. That's one of those important identities that you need to know. So now the square root of secant squared is just secant. So on the top I have secant squared theta. And on the bottom we have 2 tangent squared theta times 2. Guess we could have made that 4. Let me do that. So this is now 4 tangent squared theta. And then we have secant theta d theta. Now these squareds, one of these squareds will cancel with the secant on bottom. So we have the integration, let's pull the 4 out, 1/4. We have secant theta over tangent squared theta, d theta. So I'm picking up, we have 1/4 secant theta over tangent squared theta, d theta. Now, back in trigonometry, those are those simplify problems in chapter 5, section 5.1, where you need to simplify this to be something else. Because I might could use u sub if we let u equal tangent theta, think through it. Du is secant squared theta, d theta. So d theta is 1 over secant squared theta du. And that doesn't cancel out. So that's not the way to go. So let's simplify it and see if that'll solve the problem. So let's put it in terms of sine and cosine. So secant is 1 over cosine theta, and it's divided by tangent squared, which is sine squared over cosine squared theta, d theta. Now remember, when you divide by a fraction, you keep change flip. Keep the first one, change it to multiply. Flip the second one, cosine squared theta, sine squared theta, d theta. So we can cancel a cosine with a cosine. And now we have 1/4 the integration of cosine theta over sine squared theta, d theta. So we're going to let u, let's try u sub again. Let's let u equal sine theta. Then du is cosine theta, d theta. So d theta is 1 over cosine theta du. Now that looks like it's going to work out well for us. So we have 1/4 the integration of cosine of theta over u squared times 1 over cosine theta du. These cosines cancel, so we end up with 1/4 the integration of 1 over u squared du. Well, that gives us 1/4 the integration of u to the minus 2 du. Know that u to the minus 2 is easier to integrate than 1 over u squared. So when we integrate that, we have 1/4 u to the minus 1, and there's a negative out, times negative 1 gives me the negative out front plus c. So we have negative 1 over 4u plus c. Now this is important because u is sine theta. So inverse sine of theta is a lot different than 1 over sine theta. So that's why you need to put your u in the denominator. Then you can really see what's happening with the sine theta. So this gives me negative 1 over 4 sine theta, because u is sine theta, plus c. Now, if we were leaving this in this answer, we would say negative 1/4 cosecant theta, plus c. But we're going to go back to our triangle. Now, when we read this triangle, we're going to read it from here. So sine of theta, let's work in this little space over here. So sine of theta equals, I know we've started this several times, opposite which is x over the hypotenuse, x squared plus 4. Then cosecant theta is the reciprocal, which it's going to be easier to use cosecant in this case. The reciprocal, which is the square root of x squared plus 4 over x. Because whatever you find for sine of x, you flip it to be your cosine. So the square root of x squared plus 4 over x. So here we have negative 1/4. And cosecant is, we just learned, the square root of x squared plus 4 over x. And then we have plus c. So we're going to put those together to be negative square root of x squared plus 4 over 4x plus c. So consider the square root of x over the square root of x squared plus 4. dx. Remember we talked about you always try u sub first. So let's let u equal x squared plus 4, and du is 2x dx. So dx is 1 over 2x du. In this case, u sub is going to work. You don't have to write it out every time. You have to think about it in your head. But if I had an x squared in the numerator, it wouldn't work. That's where it is going to fail. So in this problem, we have x over the square root of u, and then du is 1 over 2x. Sorry, dx is 1 over 2x du. So these x's cancel. I'm going to pull my 1/2 out front. The integration of u to the minus 1/2 du. So when I add 1, it becomes u to the positive 1/2. And when I divide by 1/2, that's just like multiplying by 2 plus c. So I end up with the square root of u plus c, which is the square root of x squared plus 4 plus c. You could do trigonometric functions, the trigonometric substitution here, but it's a whole lot harder. So work smarter, not harder. They do give you an example where you can use the letter A and see it, but I don't think it's necessary. There will be a part B, so keep watching for it. There will be a version 2, so you can watch for that as well. Thank you.